And you are of course most welcome. This is Project Euler problem number 14, longest Collatz sequence. So the Collatz sequence is an iterative sequence. We start with the number n, and if it's even we divide by 2. If it's odd we multiply by 3 and add 1, and we keep doing this until we reach the number 1. Now it's thought that every integer eventually resolves to 1, although there's no way of proving this because obviously there's an infinite number of integers, and that I believe is the Collatz problem. So, oh yeah, it's stated right there for goodness sake. So, which starting number under 1 million produces the longest chain? Okay. So, easy way to brute force this. So, I would like to know how long it takes. So, from time import time, and we'll set a clock running. Oh, that's right, yeah. There. Def Collatz n. So this is a function that takes a number n, finds the length of the Collatz sequence, and then returns the length. So count equals 0 while n is not equal to 1. If n mod 2 is 0, then what do we do? Oh yeah, we divide by 2. So n divide by 2. If it's odd, then n equals 3 times n plus 1. And then we add 1 to the count like that, and then return count. There we are. So that's the Collatz sequence, and then we loop through all the numbers up to 1 million and find the one with the longest sequence. So we'll need to know what is the biggest starting value, so we'll set that to 0. We also need to know what is the current longest sequence. So we'll set that to 0 as well for I in range 1 up to 1 million. I don't think we need to. Oh, does it say below 1 million? Which starting number under 1 million? Yeah, so we don't need to include 1 million itself. Right, good. So for I in range 1 up to there, we'll get the Collatz sequence for the current number. So current equals Collatz I. And then, what are we going to do next? Oh yeah, if current is bigger than longest, then biggest equals I and longest equals current, and at the end we want to print off biggest. These variable names are not terribly helpful, so maybe I could rename that to biggest starting value and longest chain. That's easier, isn't it? So that becomes longest chain. It's way less effort to copy it. I should have just typed it out. I don't know why I'm doing this. Biggest starting value. There we go. And down here, starting value. Right. We want to know the time as well. So time minus s. There we go. Right. I'm going to get rid of Chrome so we can all see how long this takes. Up here. Go. Right. And there we are. So that took 43.5 seconds to come up with the correct answer. So clearly there's a lot of room for improvement here. So I will go and get a drink, and then I will discuss some ways to do that. Right then, we're going to use a thing called caching to help us make a nice speedy algorithm for this problem. So let's say we want to find the longest Collatz sequence for starting values 1 to 10. So 1 has a Collatz sequence of 1 because it's just itself. 2 has a Collatz sequence of 2 because it's just 2 and 1. What about 3? So it's an odd number, so it's going to go around the houses a little bit. So it goes to 10, then 5, then 16, 8, then 4, and then it goes to 2. Now we already know the Collatz sequence for 2, so we can stop there. So we know that 3 is all the terms in the current chain, that's 6 of them, plus this 2, that's 8. And now we also know the Collatz sequence for all the terms in the chain. So 10 has a Collatz sequence of these 5 plus the 2, that's 7. 5 has a Collatz sequence of 6. 16 has a Collatz sequence of 5. 8 has a Collatz sequence of 4. And 4 has a Collatz sequence of 3. And we're done. So as well as finding the Collatz sequence for 3, we've also found them for 4, 5, 8, 10 and 16. If we run into any of those numbers in any subsequent sequences, we can just stop and take that value. So 6, now 6 goes immediately to 3, and we know 3 has a sequence of 8, therefore 6 must have a sequence of 9. 7, this is going to be a long one. 22, 11, 34, 17, 52, 26, 13, 40, 20, 10. We know that 10 has a Collatz sequence of 7, so 7 must have a Collatz sequence of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus the 7 is 18. Now I'm going to pretend we've cached all these values and just, because that's going to take forever otherwise. 9, what do we do for 9? So 9 goes to 28, 14, 7, now we've got 7, so 9 is just these 4 plus 18, so it's 22. So 9 has the longest Collatz sequence for all starting values under 10. So let's see how we actually code that up. Okay, so let's have a go at actually coding this. I've started a dictionary. So we've got a dictionary here to cache the values in, and I've put some values in already because we know that 1 has a Collatz sequence of 1, 2 of 2, 4, 3, 8, 4, 16, 5, and you can go up through the powers of 2 all the way up to a million, but won't save you an awful lot of time. Okay, so next we're going to start the loop. So round about here, obviously we need a looping variable, so we'll start with n equals 3. We've already got 1 and 2. We need largest starting value, and we also need longest sequence. I'm not going to spell them out fully because we'll go off the page otherwise, so we'll just call it those. We'll set them both to 0 while n is less than 10 to the 6. While n is less than 10 to the 6, we will do our loop. So if n not in, so we're only interested in values of n which are not already cached. So if n not in C sequences, current sequence, let's have a variable there, and that's going to be an integer produced by a function. So current sequence is get length of sequence with a parameter n, and then if current sequence is bigger than the longest sequence, then longest sequence equals current sequence, and largest starting val equals n. If n is in the sequences, then we just add 1. Oh, and plus equals 1. We always want to add 1 to n just to keep incrementing it. So that's that. And then we want to do the actual function. God help me, this is going to be ugly as hell. So the function is going to do two things. It's going to generate the Collatz sequence for the current n, and then it's going to cache the values. So you should probably write two different functions for this, but I couldn't be bothered. Def get length of sequence for n. Okay, so I'm going to do this. Current start val equals n. I'm doing this for a very specific reason, which I will show you later. This is going to be a while loop, so we'll have found equals false. We could just do while true and then break. That would probably save a couple of lines. While true, if n mod 2 is equal to 0, then n divide equal 2, else n equals 3 times n plus 1. So that's that. So that updates, that finds the next value in the Collatz sequence. Then we've got to see if the new n is already stored in our dictionary. If it is, we stop the loop. If it isn't, we add n to the array, which I should have, list, which I should have initiated up here. So I'll call it current for a current sequence. And current sequence always starts with a single element, which is n. Okay, so we've done that, and then if, I'll do it one down. If the current n is in C sequences, then we simply break out of the loop. Else current dot append n. That should do it. So that's it for the loop, I believe. So that's how we generate the Collatz sequence for n. Now we've got to cache those values into our dictionary. So while, how we're going to do this is we're going to take the leftmost element in our current sequence, work out its Collatz sequence, and then add it to the dictionary. So while, and then once we've done that, we delete it. So while length of current is greater than 0, C sequences current 0, so we start with that one, equals, now what's it going to equal? So it's going to be the Collatz sequence for n, because we loop through until we found a Collatz sequence for n up here, plus the length of the current sequence. So C sequences n plus length of current. And then we simply lop off the leftmost value in our sequence. So we do this. Current dot remove, and I can't think of a better way to do this. So current 0. It's awful, but there we go. Right, and then return. Now we want to return the Collatz sequence for n, but we had to change n during the function, which is why I saved it up here. This value did not change, so we will return C sequences current start val. Ugly as hell, but there we are, and I think this should work. I am going to remove Chrome so that we can all see how long this takes. Now bear in mind the original algorithm took between, what was it, 54 seconds when we just looped through every value, and 22 seconds when we looped through just the even numbers. So let's see how long this takes. Bit nervous. There we go. Boom. Oh, it didn't print. I didn't. Goodness sake, schoolboy error. I didn't do this, did I? Print largest start val. We want the time as well, so time minus start. Well, that was embarrassing, wasn't it? Anyway, let's see if this works. 0. Oh, another schoolboy error. I named the variable incorrectly. Try it again. And we get the correct answer. Finally, 3.7 seconds. That's a lot quicker than the original algorithm. I'm just going to try it. Because we start at n equals 3, I'm just going to try and see what happens if we only do odd numbers. So this will go 3, 5, 7, 9. Let's see how long it takes. Can you actually see that? Yes, you can. 3.6, no saving at all. That's interesting. I'll try that again. Yeah, very little difference. Okay, let's start at 500,001, because I've heard a rumour that if you start here, it's actually a lot quicker. And that rumour is complete bollocks. So, yeah, I'll just stick to how it was. So that's it pretty much for today. Thank you very much for sticking with me through all this crap. And I shall see you next time when we look at problem number 15.